Our best explanation for this most recent phase change of the universe is dark energy, and so for the entire history of our solar system, we have been living in a dark energy-dominated era. As with dark matter, cosmologists still don't have a good idea of what dark energy actually is. When Einstein was formulating his theory of general relativity, he introduced the idea of the cosmological constant representing the intrinsic energy of empty space. As space expands, there is objectively more of this energy, which could serve to drive further expansion. In the end, general relativity didn't need this modifying constant, but the idea has found new life in explaining away dark energy. The problem remains, however, that we do not understand why such an intrinsic energy should be present at all. If the explanation cannot be found when searching on cosmic scales, perhaps the physics of the very small holds a clue. Quantum theory predicts a phenomenon known as vacuum energy, in which the virtual particles that spring spontaneously into and out of existence due to random quantum fluctuations exert a pressure, causing expansion. It is a promising idea, but calculations that apply this vacuum energy to larger scales come out far too high to properly explain the expansion that we see. Some cosmologists are considering something entirely different, a new kind of energy field called quintessence, which acts in the opposite way to normal matter, and normal energy can either be attractive or repulsive and can change its behavior over time. But without experiments or observations that can easily probe that force or even confirm its existence, we are left stranded in the dark as time ticks by and the space surrounding us expands. And so, whatever it is, we are left with a universe that is approximately 68% dark energy, 27% dark matter, and less than 5% normal matter. And it is from these ingredients that our universe has grown and developed over 13.8 billion years, following the rules and constants that were evident in its very first moments, in the first 10 tredecillionths of a second after the Big Bang.